Um, we are going to work on factoring trinomials, but we're going to add a little bit something to them. So far we've factored problems that look like this first one, x squared minus 2x minus 15. And to factor that, what it means to factor means to write it as a product. And when you're asked to factor, that means tell me what did you multiply to get this. And we know that it looks like two binomials being multiplied together because we know we got this by doing FOIL. So the first term has to give us this, or the first terms rather have to give us that first term in the trinomial x squared. So we make it x and x. Then we ask ourselves what times what is negative 15, and added together is negative 2. And it's always that. What added together is that middle number. And so we went through, we did 1 and 15, 2 doesn't, 3 and 5. Okay, now 3 and 5, I could get 2 if I subtracted them. So to get negative 2, the bigger one has to be negative, so it'd be 3 minus 5. That would give us negative 2. So then I go, and also a positive times a negative gives us a negative. So that's great. All right, plus 3, and all right, minus 5. And you're done. And now you can, of course, check yourself by foiling. But that's how you factor. So now let's take a look at this next one. We see that it doesn't start with an x squared, or it doesn't start with an a squared. It starts with 4a squared. And we saw a few of these last time, and that was okay because we would check first. We always check first to see, is there a GCF? And we hope that this 4 is a GCF is something I can take out. But, looking at 7 and looking at 3, it's not. I can't do that because 4 doesn't go into 7, 4 doesn't go into 3. So it's not a GCF. So now let's think, could we factor this? Could we figure out what times what gives us this? Well, let's start by writing these. And we know, okay, maybe it's 2a and 2a, because 2a times 2a gives us 4. What about 3? Well, that's easier because there's only 2 options. So let's do 1 and 3, and we'll make them positive. Now let's FOIL and see if that's right. 2a times 2a is 4a squared. 2a times 3 is 6a. 1 times 2a is plus 2a plus 3. 4a squared plus 8a plus 3. So that middle isn't correct. All right, well, what if instead of 2 and 2, we did 4a plus 1, and we did 4a plus 3. I'm not 4a. We don't need 4a, we need just a. Because otherwise that'd give us 16. All right, so let's try that. So that'd be 4a squared plus 12a plus a plus 3. Well, I know that's not going to work because I got 12a, so that would give us 13a in the middle, and that's not what we had originally. But, the thing is, you could also rearrange that. You could make it 4a plus 3, and then I keep doing that, a plus 1. So switching the 3 and the 1. Now, why does that matter? Because look what happens when I FOIL it. 4a squared plus 4a plus 3a plus 3. And there we go. Now we have 4a squared plus 7a plus 3. So there, I've got it. These are the factors. Of that problem. But wasn't that painful? And imagine, we got lucky because 4 can only be 1 and 4, 2 and 2. And 3 can only be 1 and 3. And so we only had to deal with a couple numbers. But what if we had something like 12? 12 could be 1 and 12, 2 and 6, 3 and 4. What if there was a negative? So there'd be so many things to try and to consider. So we thankfully don't have to do this by trial and error. We can come up with a way to know how to do these without having to guess, which is good because that was a lot of work and that was an easy one. So I'm going to erase all this just to give me some space. And let's look at how to actually do this. So there are two ways in which you can factor these. I'm going to show you both, and you can pick the way you like to do it best. So the first way is going to be factoring by grouping, which is what we learned to do earlier. And a lot of teachers will teach you to do it like this, but which is fine. Factoring by factoring, that's good. That's not what I meant to write. Factoring by grouping. A lot of teachers will teach you this way, and you'll see it in books, or you'll see it on the internet, but it's not the only way to do it, and I prefer the other way, but I'm going to show you this way just for fun, because it might work for you, and you might like it. All right, so the issue, what was the issue? The issue was, it keeps going back to eraser. What was the issue? The coefficient of 4 and the fact that the 4 isn't a GCF, so it's stuck there. Okay, so the first way we can do this is factoring by grouping, and we have to deal with this 4. So what we do, normally we would say what times what is 3. Now we're going to multiply 4 by 3. So you always multiply, this is the first term, 4, and the last term, 3. Now, generic form of this is ax squared plus bx plus c, where a is the coefficient of the x squared, b is the coefficient of the x, one in the middle, and then c is the constant at the end. And so you'll always see a quadratic or anything that's written with x squared as ax squared plus bx plus c. And so you will always multiply a to c. Multiply a to c. So 4 and 3 could change depending on your problem. You could have different numbers, but you will always be multiplying a to c. So ac, a times c. That's this is what, ac. All right, so then we get 12. So now we ask ourselves, so first thing is multiply by, or 4 to 3, or a to c. 2. You're going to find two numbers whose product, that means they multiply together, is that number that you just got. Is, so in this case 12, and their sum is 7. Just like always, like it's always what times what is the last number and added together is the middle. Now we've had to multiply a to c, and then we still say what added together gives us the middle number. Okay, so what times what is 12 and added together is 7. So positive 12, because those were both positive, and 7. So that's definitely 3 and 4, right? All right, so what you're going to do is then you're going to take your problem. So you find the numbers, step 3, plug them in the middle. And you replace, so I guess I should say replace the middle, because you're going to take 7a out. So it would be 4a squared. You could write plus 4a plus 3a, because these are the two numbers that I found right here, right? And then plus 3. So see, I have taken 7a out, and I put in for it 4a plus 3a. Now that makes sense, because 4 plus 3 is 7. So it's just a different way to write it. So now that you've replaced it like that, you're going to factor by grouping. So for group. So let's see, I can take out a 4a from the first term, so it'd be 4a, and I'd be left with a plus 1. And I can take out a 3 from the next two, and I'm left with a plus 1. So then what does that factor to? It factors to 4a plus 3 times a plus 1. Or switch the order, you can switch the order. But that is how you factor it. All right, so the main thing that you have to understand is that you have to multiply a to c. And you have to do that anytime your a is bigger than 1 and it's not a GCF. Anytime a is bigger than 1, which you might have seen me write in our notes. Like last time a equaled 1 because the coefficient was 1. Here a is bigger than 1. All right, so that's one way to do it. You can factor by grouping. Here's another way. You still have to multiply a to c. So the first step, I call this AC factoring. So the first step is to multiply a to c. And you do the same process. You say, okay, what times what is 12 and added together is 7. So I have 12 and I have 7 and I still know it's 3 and 4. So then I write, so that's step 2. Step 3, I'm going to factor and plug those numbers in. So I factor like I normally would, as if there wasn't a 4 there. I would write a, and then I write the two numbers, plus 3 and plus 4. Now, that is not the answer, because if I FOILed that out, I would get a squared, which right off the bat is wrong, because I need 4a squared. So here's the next step. This is the kicker, and this is what makes this work. Divide those numbers by whatever a was, whatever you multiplied that last one by. So it'd be a plus 3 and a plus 4. So you're going to divide those numbers by, what was a? A was 4. Now you reduce if possible. So like the second one, 4 divided by 4 is 1. So then it will become a plus 1. In this next one, if it doesn't divide or if it reduces and then you're still left with a denominator, circle it and draw an arrow moving it up. This will help your muscle memory remember that this is what you do. 4a plus 3. You've moved it in front. And look, boom, same answer as what we got before. So to me, this is just way easier. It's you don't have to worry about factoring by grouping. I really like this way, AC factoring. But you, of course, can solve it however you like. All right, so we're going to look at some more examples and just keep practicing this. And I'm going to do it the way that I like to do it. If we have some issues with that, like if you don't like it that way, then you can reach out to me and we'll do it by grouping. But okay, so I'm going to do, look at this. Is there a GCF? No, there's no GCF. So first, is there a GCF? No. So step 2, I notice that a is greater than 1. In fact, a is equal to 4. So then I have to multiply a to c. So I do 4 times negative 4. I have to keep into account that that's negative, so I get negative 16. So I'm going to find two numbers that multiply together to give me 16 and add together to give me negative 15. All right, so let's see. I'll make my chart 'cause that's what we've been doing. Negative 16 and adds to give me negative 15. So let's see. 1 and 16 would work because I could do a negative 16 and a positive 1. Negative 16 plus 1 is negative 15. So that would work. That's a negative. Oh, that looks good. All right, so now I'm going to factor. Now remember, you just do it like you would as if that A wasn't there. So it'd be V and V. Okay, you put those numbers that we just found in there. So negative 16, positive 1. Order doesn't matter. And here's what we always forget. Divide. So I'm going to even write this here. Divide these by A. So I write them over 4. Now, if they reduce them. So this will be V minus 4, because 4 goes into 16 4 times. And this one doesn't. So what do? Circle it, draw an arrow. It's going to move up in front. And now you have done it. You have you've factored using AC factoring. All right, this next one. First, I'm going to look, is there a GCF? No, there's no GCF. All right, so 4 and negative 12. Let's see, 4 times negative 12 is negative 48. What times what is negative 48? And added together is negative 13. 148, 2 and 24. 3 and, let's see, 1, 16. Hey, that would give 13. If we had a positive 3 and a negative 16. All right, so factor them just like I would before, A and A. And then I have plus 3 and minus 16. Again, the order of those numbers doesn't matter. The signs matter, but the order doesn't. And then I divide, here's what everyone forgets, divide by A. So A was 4 and 4. And so then reduce if possible, and if not, move it. So 3 and 4 doesn't reduce, move it up front, so it'll be 4A plus 3. That one reduces A minus 4. Boom. That is your answer. Okay, now, of course, you get to practice these. So, what I want you to do is pause the video, work these problems out, unpause the video, and you can see if you got the same answer as me. All right, go for it. All right, so here what we do is look for a GCF. There's no GCF, so I'm going to do 4 times 6, and that is 6 times 4 is 24. So what times what is 24? And added together is negative 11. Ooh, a positive. So that, but add together give you a negative. That means they're both negative. So let's see, 1 and 24, no. 2 and 12, no. 3 and 8, yes. 3 times 8, but they both have to be negative. So negative 3 and negative 8. I know that because a negative times a negative is a positive, and a negative plus a negative is a negative. All right, so I just write x minus 3 and x minus 8. Divide those numbers by 4. If they divide, great. If not, move it up in front. So this will be 4x minus 3, and this is x minus 2, because divide that by 4, and that's 1, and divide that by 4, and that's 2. So that's 2 over 1, which is 2. And there you have it. Next one. So let's see, no GCF. So then I'm going to do that times that. So that's negative 8. What times what is negative 8? And added together is positive 7. So that's going to be 1 and 8, and 2 and 4. So it has to be 1 and 8. It has to be negative 1 and positive 8 to give us a positive 7, but a negative 8 when we multiply. So x minus 1 plus 8. Divide those by a, which is 4. Reduce if possible, and if there's a denominator left, move it up. So there's a denominator left, move it up. 4x minus 1 and divide by 4, so that's 2, so it'd be x plus 2. Nice. All right, let's see. Should I do these by grouping? No. All right. Big number. 4 and 15. So let's see. I know there are 4 15-minute increments in an hour. 15, 30, 45, 60. So I do 4 times negative 15. So that gives me negative 60. What times what is negative 60 and added together is 17. So 6 and 10, no. Let's see what else. Let's maybe start from the beginning. 1 and 60, no. 2 and 30, no. 3 and 20. Yes. Okay, there we go. So I need a negative 3 and a positive 20. And then I write K and K. And I write negative 3. And I write plus 20. And then I divide those numbers by 4. And like I can see this one, that will reduce by, that goes into it 5 times. So K plus 5. How am I getting 5? Because 4 goes into 20 5 times. Dividing by 4. And then this one doesn't divide into it, so I just move it up. 4K minus 3. And you can always check these, right? If you FOILed this, 4K times K, 4K squared. This times this would be 20K. This times this, negative 3K. Boom, that's what gives me the 17K. And then minus 15, minus 15. So that's right. All right, we are getting close to the end, and I think this is, I'm about to stop. So right here, we're gonna look at this one now. Ooh, what's the first thing I'm always looking for? I keep saying it every time. GCF. Is there a GCF? So always look for that first. Is there a GCF? Because otherwise you can end up doing a whole lot of work and it would be wrong. 6 times 20. That would be 120. That's massive. See, I gotta check for a GCF first. Is there a GCF? Yeah, let's see. 2 definitely goes into all of those. So if I divide by 2, let's see what I get. I have 2, and then I've got 3v squared minus 13v plus 10. Much better. But I still gotta see if I can factor this. So, carry down the 2. I'm gonna have my factors, v and v. But how do I do this when a is bigger than 1? I have to do AC factoring. So I do 3 times 10, and I get 30. So what times what is 30, and added together is negative 13. I love these. 3 and 10, right? Okay, so they both have to be negative to get a negative 13. Oops. So, minus 3, minus 10. We always forget, but divide by a. So 2, bring that down, v minus 1, and then that doesn't go into 10, so it'll be 3v minus 10. And you have factored this incredibly tough problem with a GCF. And that is where we are going to stop for today.